So for chapter 15, I did number 11, and it gives us 3 charges, and it's asking to find the magnitude and direction of the force at origin. So the one at 5, right? And so if we draw this over here, we get this. And as we know, if it's a positive and a negative, they'll attract. So if we want to find the overall direction, the 5 will go down right here. But right here, they're the same, so they repel, and so this one will go this way to the left, and that means the overall direction is this way. And if we see that it makes a triangle, the force will make a triangle. So we know that to find force we need to find C, and I just named them A, B, and C. So force A, force B, force C. And so first, like to start it off, you're gonna notice that there's an N next to the letters, and next to the coulombs, and we know that N is equal to 10 to the negative 9. And so if we, for example, do 5NC, it's 5 times 10 to the negative 9 coulombs. And so we first want to find, well, we can find B and A because we have our radius and our charges for both of them. So we're going to use the equation, the Coulomb's equation, and its force is equal to the constant and the absolute value of the two charges over the radius squared. And so first, I wanted to look for the top one, charge A. And so we get the equation, force equals 9 times 10 to the 9 newtons times meters squared over coulomb squared, which is the constant for all of them, times 5NC times 6NC, absolute value of both of them, over the radius squared. And so for A, we get the force is 3 times 10 to the negative 6 newtons. And so we found A, right? Now we need to find B. So for B, I did the same thing, except now we have to use -3 and 5. So we did that, an absolute value. So the -3 will just be a 3 in your calculator, over 0.1 squared. And so the force of B, I get 1.35 times 10 to the negative 5 newtons, rounded. And so now that we found both forces, since this is a triangle, to find the force of C, we can do A squared plus B squared equals C squared. So C is going to equal root A squared plus B squared. And so you can see that right here. If I plug my numbers in, I'll get about 1.38 times 10 to the negative 5 newtons. And so we found the magnitude, right? But now we need to find direction. Well, we already know that the direction will go down this way. So we should find the angle right here. So to do that, I did theta equals inverse sine of B over C. So opposite over hypotenuse. Pretty simple stuff. And so I get theta equals inverse sine 1.35 times 10 to the negative 5 newtons over 1.38 times 10 to the negative 5 newtons. So just the two forces that you found. And so if we put that in, we get 78 degrees below the horizontal because it's going down and the origin is right here, right? So it's below the horizontal or the X. And so we have our force found. We found our force. And now we have our direction. So the answer will be force of 1.38 times 10 to the negative 5 newtons at an angle of 78 degrees below the horizontal. And that's how you solve number 11.